Okay, so we will go ahead and get started with the seminar. So welcome to this month's edition of Pigments 101. Today we are going to review the High Performance Azo Pigments. Don't mind my dog there. So as we've done before, I will record this this webinar and make it available to all of the participants of today's call, and I will also send out the PDF of the presentation as well. If you have any questions throughout the webinar, please use the chat screen and we will address those at the end of the presentation. And with that, we will go ahead and get started. Keep my phone there. And we are talking about the high performance azo pigments, and there are two classes of high performance azo pigments. The first one is the benzimidazoline, and the second is the diazo condensation type of pigments. In this screen, I'm providing you with the CIs, color indexes that are available in each of these two types of class of pigments. These are those that were at one time created for the pigment industry. But however, just like everything else, some of these go by the wayside and are not valued in the industry, so they are taken out of the industry. So the second screen, I'm leaving in each category those color indexes that are still commercial in the industry. And most of that cleaning out has been done in the disazo condensation class of pigments. Today, we will review the highlighted color indexes that I have in both categories. So you'll get a sense of these chemistries and what they bring to your colorant needs. So as far as an introduction, since we've discussed the classical azo pigments already, there have been efforts to improve those technical properties of the azo pigments, classical pigments, especially with an effort to improve the fastness properties as well as bleed resistance and heat stability to bring that color need from the azo to a more of a high performance pigment property catalog. Two approaches were developed that proved successful in getting these improved technical properties. The first one was created by SIBA, which is creating the disazo condensation pigments, and in this case the pigment molecule is enlarged to create that improved properties. And the second method was to lower the solubility of that pigment molecule, as is done with the benzimidazoline class of pigments. So for benzimidazoline, these have been developed in the mid-1960s and early 1970s, so a fairly new class of pigments in the scheme of things. And in this case, that lowering the solubility of the molecule really improved the light fastness capabilities versus the previous classical azo pigments in those similar color spaces. The base structures are seen here in this class of pigments. The red and brown colors were developed first in the 1960s with the following base structure, which contains the benzimidazoline moiety in that boxed areas. And then the individual color indexes are created by attaching a unique moieties in the 1, 2, 3 positions located in this base molecule. However, the yellow and orange pigments in this class have a slightly different base structure. However, the unique color indexes are similarly achieved by attaching the specific moieties in the R1, 2, and 3 and 4 locations, as indicated here. The only exception to this class of pigments is the pigment orange 64, which is created in a unique way, which I will review a little later in the presentations. And the yellow and orange pigments of this class came along in the 1970s. The disazo condensation class of pigments contain 2 azo groups carry over from the classical azos, but also structural units are condensed onto that chromophoric system, and that is what gives the improved properties. Those condensation activities with the structural units do make these one of the most complex class of high performance pigments that there are, with molecular weights of achieving 1,000 or more, so very large molecules. This class of pigments was developed in the early 1950s, and they are built up using 2 aromatic amines in different ways. The first way is a carryover again from the classical azo pigments by creating that disazo base. And then the second one is these are condensed onto what we're calling a condensation base, and you'll see that in the structure discussion in a few moments. Chemical abstracts list about 550 registry numbers for the diazo condensation pigment class, but more than 10,000 exist that have been discovered and developed, but not all of them actually get to that chemical abstract listings. However, this dwindles down to only about 20 have ever been launched to the marketplace. And today there are about 14 that are still being used in the industries. Excuse me. As I mentioned, the yellow disazo condensation pigments are formed using this base molecule, and as I mentioned, the center portion of this molecule is the condensation base located in the A position in the center, and then the disazo bases are attached onto the ends in the B location, and so you can see how large these molecules can get depending on what those attachments are, create those. Like the benzimidazoline class of pigments, the orange, red, and brown have a different base that they're used, but they're put together in the same way with the condensation base in the center location, A position, and the disazo base attached on the end in the B locations. The high performance azo pigments are used in all of the applications in there. Primarily, they're taking advantage of the chromaticity, and then of course the extended technical properties of fastness, weatherability, and heat stability are those that make extension into all of the applications possible. Benzimidazoline pigments have been particularly useful of late over the last several years for those customers who need to replace heavy metal pigments in their formulations and get away from those types of pigments. The benzimidazoline pigments are very good for that particular application. So we've talked in the past about both classical and high performance pigments, and the high performance azo pigments are really focusing on the fastness properties and the heat resistant properties, which bring them into the high performance category of pigments in here. So I've got a couple of examples that I want to share with you that gives a better feel for how that movement from the classical to the high performance occurs. So this first example that I have for you is comparing the classical pigment red 2 to the high performance pigment brown 25. These I grant you are not the same in color, but they do have a very similar structure in the base structure. So everything below the box is exactly the same. However, the attachment moieties that are used make the difference in the properties. Where the classical high pigment red 2 uses a phenol ring in that position, whereas the benzimidazoline moiety is added for the pigment brown 25. And how this difference translates to the technical properties is shown here. And again, primarily focusing on the fastness area, you see a marked improvement in the light fastness in all shades and reductions. A significant improvement in heat resistance and fastness to bleeding. So all of a sudden, that change in moiety on that base structure allows this type of a pigment to be used in plastics application, whereas the similar structure pigment of the classical sense cannot be used in plastics. The second one I have brings in the disazo condensation type of pigments. And in this case, both the pigment red 146 and the pigment red 185 are both similar in structure and color in this particular case. And what I have boxed in here is the disazo portion of that, which is the carryover from the classical over into the high performance. And then on the ends of that dictate what makes it the high performance or the classical pigment. And how these two differences relate to technical properties is shown here, where we see an improvement in the light fastness, especially in the reduction with TiO2, and a marked improvement in fastness to bleeding, especially for plastics. The one drawback that some high performance pigments, high performance azo pigments have with respect to their equivalently colored azo pigments, classical pigments, is in the strength weakness in here. In this case, the very, very large molecule in the case of the disazo condensation pigments, or the very low solubility, tight structure of the benzimidazoline can impede the strength of the pigment versus an equivalently color azo classical pigment. So now we'll move on to some examples of the benzimidazoline area. The first one in this series is the pigment yellow 155. This is a very clean green shade yellow pigment. And in each case, obviously, some of the performance properties are what we're talking about today and are very light, fast, and durable for coatings. However, these are also used in plastics and inks as well. And in each case that I share with you today, I'm highlighting in the red boxes that are flashing on your screen what makes the color index unique, and what specifically is the moiety and the location of that moiety attached onto the base molecule. So for Sudarshan, we have a couple of products that we have in our portfolio for Pigment Yellow 151. We have one for the coatings and one for the plastics. And as I've always stated before, that these are placed in these particular buckets primarily because of the finishing techniques that we put onto the pigments, where these are generated directly for those particular applications. However, it's not to say that the pigments can't be used in other applications. So I'll continue to reiterate that particular point. As far as the crystal shape, the Pigment Yellow 151 is more of a rod-like in shape, as can be seen in this TEM, where the length far exceeds the width of the crystal. The next one in the series is Pigment Yellow 154. This is moving a little bit more to the red side from the Pigment Yellow 151. And this particular color index is one of the most weather-fast yellow organic pigments that is available. And so this is highly used in all applications for that particular reason. However, there's one negative, if you could call that, is that this one does have a lower strength in comparison to other organic yellow pigments that are similar in shade. But you get the fastness properties that might be required for your application. The crystal shape for the yellow 154 is more of a block-like shape. As you can see here, the length and the width of the crystals are more similar to each other, making it more of a block-like. And for Sudarshan, we have one Pigment Yellow 154 in our portfolio that has finishing steps that are deem it a very good for coatings applications, but it also is very efficient in plastics and inks as well. Next in the series is Pigment Yellow 180. This is more of a medium shade yellow pigment. It is extremely heat stable and doesn't affect shrinkage in plastics. So it works really well for that particular application. But that particular, the heat stability makes it also useful for coatings and inks where a high temperature curing system might be a need for that application. So this particular pigment would be a good use for that application as well. It gets its heat stability from its ability to bond more than one molecule together in a very tight, compact aggregate. And you can see how that would be. So it makes it takes in consideration the low solubility of the benzimidazoline groups, but it also makes the molecule bigger, similar to the disazo condensation pigment. So you get sort of a double effect on your property performance by those two aspects of this particular pigment. Like the Pigment Yellow 151, the Yellow 180 is more rod-like in shape, as you can see here. And for Sudarshan, we offer two that we currently have developed for the plastics industry, but we are seeing the use in other applications as well. Moving into the orange space of the benzimidazoline is the Pigment Orange 64. And this is a very, very nice yellow shade orange pigment with great opacity and very heat stable. However, as I mentioned earlier on, this is one of the unique pigments in the class of benzobenzodazolone pigments. It's unique in that the benzobenzodazolone is coupled onto barbituric acid and not the standard base molecule that the other pigments are put on. So this difference does yield a lesser weather fastness properties, especially with in the presence of TiO2. So your medium shade to pastel type shades is not a color space that you would use this type of pigment in, especially if you need to have a exterior weatherability need for your coloration. Orange 64 is more like the block shape with the length and width similar in size. And we have a number of products in this category for our portfolio, a couple in the plastics area and one in the coatings area. But they can, like all others, can be cross functional in the other applications as well. The last orange in the category is the orange 36. This is a workhorse pigment. Almost everybody is very familiar with this particular color index. It's a red shade orange pigment with very, very good light, weather, and overspray fastness. It's used in all applications in there, and it is also more of a block shape in the crystal structure. And Sudarshan offers 3 versions of the pigment orange 36. These were originally developed for the coatings area, but do very nicely in plastics and inks as well. Moving on to the red space in the benzobenzodazolone category is the pigment red 175. This is a somewhat dull red pigment with good fastness properties. Primarily, it's used in coatings and plastics because it's a nice transparent in color. And the other red is the pigment red 185. This is a blue shade red pigment, very high heat stability and strength. It's got excellent solvent fastness, which makes it a very good tool for graphics printing, but it also can be used in plastics and in coatings. Pigment violet 32 is the one violet in the benzobenzodazolone category. It is a very somewhat dull, very blue shade red pigment. It does have some issues with it is heat stable. However, its usage is not very large in the pigment industry, primarily because you can get to this same color space with other high performance pigments. For example, pigment violet 19, the gamma version, red 122, or even red 264 are other more prominent high performance pigments that can give you the same technical performance and get you into a similar color space. So this particular pigment is kind of losing its stride in the industry. And the last one in the category is a brown, the pigment brown 25. It's a very lovely red shade brown pigment, which is very unique in that it gives it's a high transparency, makes it especially useful for effect colors in that brown space. And then moving on to the disazo condensation pigments, we'll start with the pigment yellow 93. It is on the green shade side with excellent heat stability and good warpage with respect to plastics. It is primarily used in the plastics and inks application areas. And as I stated earlier, the intent of the disazo condensation class of pigments is to make the molecule large. So you can start to see how that is with depending on what the moieties are used in those disazo base and condensation bases in the A and the B location. The next yellow is the yellow 128. This is more of a neutral yellow shade pigment. It has more light fastness than the pigment yellow 93 that we just discussed. Its main use is in plastics, but I do want to point out that with this particular one, we talked about enlarging the pigment, and this molecule is quite large. So you can see that with this structure here. Moving into the red space, there are taking a look at the pigment red 166. It is a blue shade red pigment with good stability. For plastic, it does have a limited use in plastics because it does have some reduced warping resistance. So primarily it is being used in ink applications. Red 242 is the next one we'll go through. It is a scarlet red pigment with excellent fastness properties. However, it does have a warping, a negative warping issue that makes it unsuitable for high density polyethylene injection molding applications. So primarily it's being used in inks and coatings applications. From a process perspective, the benzimidazolone and the disazo condensations do have their starts from the classical azo pigments that we discussed a couple of months ago. So the diazotination of the amine is one of the first steps, along with a coupler preparation. In this particular case, there is a unique coupler for yellows and oranges and one for the reds. However, they both start with the benzimidazolone raw materials to create the coupler. The coupling then is carried out in an aqueous medium, and in this particular case, the process during the coupling is that the components are first they're dissolved in an alkali and then reprecipitated back into an acid in the presence of the surfactant, which creates their activated form. And it's this activated form that gets the finishing treatment to create the final pigment. And as far as the important properties and steps in the manufacture, the thermal finishing is what is probably the most key in terms of creating the correct end product that you're looking for. The product is heated anywhere between 100 degrees and 150 degrees C under pressure, and that set of conditions creates the crystal shape, phase, size, and the distribution of the pigment. And of course, all of those create the shade, strength, opacity, light, and weather and solvent fastness, as well as its dispersibility. So this final finishing treatment is the key to creating that final end pigment and the properties that come along with it. For the disazo condensation, again, starts very similar as the classical azo pigments, and that we are creating that disazo base, that B section of the molecule is created first, along with a coupler solution. And then once the material is coupled together, is converted to an acid chloride version, and then the condensation occurs with that condensation base, which is the A section of that big molecule. Unlike the benzimidazolone, the condensation process is carried out in an organic solvent in there, and then the final treatment is a similar thermal treatment, but not as critical as the benzimidazolone class of pigments. So our class of Sudarshan has the benzimidazolone included in our Sudaperm brand of high performance pigments. As you could tell, we do not currently participate in the diazo disazo condensation pigments at this time, but we do have quite a selection of the benzimidazolone pigments for your colorant needs. From a color space perspective, I just wanted to give you a feel for where they fit. These products fit in with other products. So today we've discussed the pigment yellow 180, the 151, and the 154 in the yellow space. So these azo pigments are more towards the greener side. So you can kind of get a feel for where they sit versus other color indexes in the yellow color space. And in the orange color space, we talked about the orange 64 and the orange 36. So you can see how much yellower the orange 64 is versus the orange 36. So next month, we will leave pigment chemistry a little bit and go and talk about pigment finishing, since I've been talking all these months about the importance of the actual finishing steps on the pigments themselves and how they interact with your systems and formulations. I thought it would be good to put a little bit more focus on this particular part of the pigment manufacturing process. So that'll be held in June on the 29th, and look to see the invitation to come out the week of the 21st of June. And then in July, we will jump back into pigment chemistry and take a look at the remaining high performance pigments in the polycyclic area. In that will happen in July. And of course, I am not one person. I am part of a wonderful team here in the North America. So you can reach out to any one of us with any of your questions, and we will be happy to answer them and support your needs with respect to pigments. And now I will open it up to any questions that you might have during the presentation. And again, if you have any questions, you could either come online or jump on the chat box as well. Okay, well, I don't see any questions here. So with that, I will close the session. And if you do have any questions after the call, you can certainly reach out to me. I'd be happy to help you in any way. And just wanted to thank you again for participating in our Pigment 101 series, and hope to see you next month. Take care, everybody, and have a great rest of your day.
Thanks, Bonnie.
Thank you.
Very good.
Thank you, Bonnie. Thank you all for attending.
Sure.